There are these invisible rules that kind of structure our whole world. They're everywhere, in the rhythm of the seasons, the numbers on our streets, even in the code on our computers. We're about to explore that fundamental human drive to find these patterns, to understand their language, and maybe even use them to shape our destiny. Sounds like a riddle, doesn't it? But the answer? Well, it reveals something really profound about how we make sense of the universe. The thread connecting these three totally random sounding things? It's the power of a sequence, basically a pattern with a purpose. So before we jump back in time or try to get inside the mind of a genius, let's just look at the world right in front of us. Turns out, patterns and sequences are so deeply woven into our daily lives that we barely even notice them anymore. I mean, just think about it for a second. When a mail carrier walks down a street, they're following a sequence. Odd numbers on one side, evens on the other, each one just going up by 2. The same logic is there for apartment floors, or how sports teams are ranked in a league, or even something as critical as a medication schedule. All of these are just sequences, designed to create order and make things predictable. And this is not a modern thing at all. For thousands of years, our survival has literally depended on recognizing patterns in the natural world. The phases of the moon, the turning of the seasons, the migration of animals. See, to find a pattern is to get a little bit of power over the world. The power to understand it, predict what's next, and eventually to control it. And there is no better example of this than in ancient Egypt. There, an entire civilization was built around the predictable rhythm of a single river, the Nile. For the Egyptians, figuring out this pattern wasn't just some academic exercise. It was a matter of life and death. The contrast here is just stark. In a land completely dominated by harsh, unforgiving desert, the Nile was so much more than a river. It was this thin, fragile ribbon of life. It was everything. The river's gifts were incredibly predictable. Every single year, seasonal rains would cause the river to flood its banks, and when it did, it would leave behind this layer of rich, dark silt called humus. It was a natural, nutrient-packed soil that made farming possible. The river also gave them water, food, and was basically a superhighway for travel and trade. The Greek historian Herodotus was not kidding when he said, "Egypt is the gift of the Nile." So the Egyptians, they didn't just sit back and watch this happen. No way. They organized their entire society around it. They created a calendar based on the river's 3 distinct seasons. First up was Akhet, that's the flooding. Then came Peret, when the waters pulled back and they could get to planting. And finally, you had Shimu, the harvest. This whole sequence, it was basically the heartbeat of their civilization. But just observing wasn't quite enough. They needed a precise trigger, and they found it in the stars. The Egyptians noticed that the flooding always started shortly after the star Sirius appeared on the eastern horizon, right before sunrise. And they calculated that this celestial event happened every 365 days. Based on this incredibly precise, repeating pattern, they created one of the world's first solar calendars. It was an absolute masterpiece of ancient data analysis. All right, so the Egyptians mastered a natural sequence through careful observation. But to really, truly unlock the power of patterns, we need a universal way to describe them. And that means moving from the language of seasons and stars to the language of mathematics. In math, a sequence is actually pretty simple. It's just a list of numbers that follows a specific rule. The house numbers on your street follow the rule add 2. The Egyptian calendar followed the rule 3 seasons repeating every year. The real beauty is in finding that rule underneath it all. Some mathematical rules are so cool you can even see them. Take these, for instance. They're called triangular numbers. You can see the pattern right away just by looking at the arrangement. You start with 1 dot, then you add a row of 2 dots below it, then a row of 3, and you just keep going, making bigger and bigger triangles. Let's just break it down real quick. The first triangular number is 1. The second is 1 plus 2, which gives you 3. The third is 1 plus 2 plus 3, which is 6. The fourth is 1 plus 2 plus 3 plus 4. That's 10. You can see the rule, right? To get the next number in the sequence, you just add the next whole number. It's simple, it's elegant, and it's totally predictable. Okay, so finding the next number in a sequence is one thing. But what if I asked you to find the 500th number? Or what if you had to add up all the numbers in a really long sequence? Well, that's where true insight comes in, which brings us to the story of a very young genius. This quote from Carl Friedrich Gauss, it just perfectly captures the spirit of mathematical discovery. For Gauss, the real thrill wasn't just knowing the answer. It was the process,
the hunt for it, that joy of uncovering the hidden pattern. And a famous story from his childhood shows this perfectly.
Okay, so the story goes like this. A teacher, probably just wanting a few quiet moments, gives his class this super tedious task. Add up every single number from 1 to 100. So you can imagine his classmates all start scribbling away. 1 plus 2 is 3, 3 plus 3 is 6, a total slog. But then a 10-year-old Gauss has the answer, like almost instantly. The question is, how on earth did he do it? He didn't do all that grinding calculation. Instead, he saw a hidden, much more elegant pattern. He realized that if you pair the first and the last numbers, 1 and 100, they add up to 101. Then, if you take the second and the second to last numbers, 2 and 99, they also add up to 101. And this pattern just kept going, all the way to the middle. 50 plus 51 is also 101.
So the next question is, how many of these pairs are there? Well, in a list of 100 numbers, you're going to have exactly 50 pairs. And just like that, the problem becomes way, way simpler. It's just 50 pairs, and every single one adds up to 101. So the answer, 50 times 101, which is 5,050. It is an absolutely brilliant shortcut, right? And it all comes from seeing that deeper structure in the sequence. This kind of thinking, by the way, finding that elegant rule to crack a complex problem, that's the foundation of pretty much all of modern computer science and algorithm design. Gauss's story really shows the power of finding a rule to master a sequence. So let's go back to the Nile. What happens when our ability to understand and control patterns gets so big it can alter the planet itself? For thousands and thousands of years, the Nile followed its natural pattern of flooding and receding. But in 1971, that ancient rhythm was brought to a dead stop. The completion of the Aswan High Dam gave Egypt total control over the river's flow, promising them things like year-round irrigation and hydroelectric power. And this is where you see the trade-off. Before the dam, you had nature providing this seasonal cycle that dropped off fertile humus for free. After the dam, the floods stopped. Now, this did allow for farming all year round, but it came with a huge cost. That natural process of fertilization was gone, which forced a total reliance on artificial fertilizers. The ancient pattern was officially broken. The scale of what they did here was just monumental. The dam created one of the world's largest man-made lakes, Lake Nasser, and it threatened to completely submerge these priceless ancient treasures. Huge temples, including the famous ones at Abu Simbel, had to be carefully cut up into enormous blocks and then reassembled on higher ground. It's just an incredible testament to both our engineering skill and the consequences of messing with natural patterns. And this brings us right back to our central theme. From an Egyptian priest charting the rise of a star to a young Gauss finding a shortcut in a math problem, our journey is one of seeing, understanding, and then using patterns. But the story of the Nile and the Aswan Dam leaves us with a really critical question. Once we have the power to control a pattern, what new responsibilities do we take on?